When measuring web performance, there are many different types of metrics which we can track. These all generally fall within the following categories: quantity-based metrics and milestone metrics. Quantity-based metrics measure things such as the number of HTTP requests, the size of the page in bytes, the number of images loaded, basically anything you can count. These are useful to monitor over time as the website grows and develops, as they can reveal trends or highlight problems with third-party scripts, for example. Milestone metrics measure how long it takes the browser to reach a specific phase of the loading process. For instance, how long the server takes to respond, how long it takes the browser to start rendering content, or how long it takes for that content to become interactive once JavaScript execution is completed. These kinds of metrics allow us to learn more about the overall user experience. Whilst quantity-based metrics are relatively self-explanatory, milestone metrics require a little more elaboration. Let's go through some of the most common of these. Time to first byte, or TTFB as it is commonly abbreviated as, is used to measure the responsiveness of a web server. More specifically, how long it takes the server to respond to the browser's first request, the HTML, once a connection with the browser is first established. Bad server config or back-end coding can be responsible for any poor performance in this area. Also, the further you are from a website's server geographically, the longer it takes to respond. Loading the same website from a server in the same city compared to the other side of the world is going to yield two very different time to first byte measurements. Once the browser has received the page's HTML, it's able to begin the critical rendering path. First, as we know, the DOM and CSS-OM are generated, which together form the render tree. Next, the browser calculates the layout and then starts to paint the website to the screen. First paint, sometimes also known as start render, measures how long all of this takes to complete. It's essentially a measurement of how long it takes between when the user types in the web address and presses enter, to when bits of website content, however small, first begin to appear in the browser window. There's also first contentful paint, which is a very similar metric. Like first paint, it measures when the first bits of content are rendered to the screen, but makes a distinction that the content must be useful to the end user. This means for the metric to trigger, the new content must be text, images, which include CSS background images, SVG elements, or non-white canvas elements. If these metrics aren't optimized, the user will likely think the website isn't loading, as the browser isn't providing any visual feedback fast enough to suggest anything is happening. In the past, it has been common to track a website's speed by measuring when the browser fires events such as DOM content loaded and load. These metrics, whilst legit measurements, aren't a very good indicator of the actual end-user experience. Why? If the browser's visible content in the viewport renders after only a second, and then 5 more seconds are spent loading content hidden below the fold, 6 seconds is the value which will be passed back in the report, even though the user was able to meaningfully interact with the website after only 1. Speed Index tries to fix this inaccuracy by measuring the average time it takes for only the viewport content to be rendered, with any below-the-fold elements now safely ignored. This also means that when comparing page loads between mobile and desktop devices, The mobile devices will always have a lower speed index, simply because there's just less viewport content to render. More recently, a performance metric named Largest Contentful Paint has gained some traction. Its goals are similar to speed index. Identify when the main content of the page has loaded. It was introduced, to quote Google, because there were concerns that speed index is too complex to calculate, hard to explain, and often wrong. Largest Contentful Paint, on the other hand, purely looks at when the largest image or text block is visible within the viewport, which would itself be indicative of everything else being visible in the viewport as well. Time to interactive measures the point in the loading process where the page is fully interactive. For this to happen, the page must be complete enough to facilitate the interaction, which makes sense as you can't interact with what isn't there. This means the page must be displaying useful content, which we're tracking using First Contentful Paint. Event handlers must be registered to this content and then also respond to user input consistently within 50 milliseconds. In addition, there is a newer metric called Time to First CPU Idle, sometimes called First Interactive, which measures when the page is first expected to be interactive in some capacity and responding to user input quickly. So to reiterate this, Time to Interactive measures when the page is fully interactive, whilst Time to First CPU Idle measures when the page is first interactive. Making sure a page becomes interactive as soon as possible is paramount to achieving a positive user experience, as if elements don't respond when the user tries to interact with the web page, it's highly likely that they'll just get frustrated and go elsewhere. Total blocking time is another JavaScript-oriented performance metric. It measures the amount of time between First Contentful Paint and at Time to Interactive where the browser was too busy executing JavaScript to accept input, which the user will perceive as slow or janky. It makes a good complementary metric to Time to Interactive, as it can help developers understand just how non-interactive a page is prior to the Time to Interactive metric point. First input delay, or input latency, represents the time from when the user is first able to interact with elements on the page to the point where these elements are then able to respond to those interactions, which depending on what the browser is doing isn't always immediately. This is because browsers are single-threaded, which in layman's terms means they can only execute instructions in a single sequence, one at a time. So, with this in mind, if page content has finished rendering, but the browser is still busy executing JavaScript, any user input during this time would not be registered, as the browser doesn't have the resources available to respond. A poor first input delay usually equals user frustration, because interactions don't appear to be snappy or responsive, which nobody likes. Depending on the tool, load time can represent a few different points in the loading process. Where the browser onload event has fired and all of the page's static content has loaded, or when the above has happened, but there's been no additional network activity for a few seconds, signalling that it's come to an end. As we've already covered, this metric is less important because it's not an accurate representation of the user's own experience of loading. If load time measures 15 seconds, but speed index is 3 seconds and time to interactive 5 seconds, then from the user's perspective, it's at this point that they can begin to engage and use the website, not when the loading is completely finished. Often as a website is loading, during the render phase, the layout of a page can suddenly shift as new elements are introduced. This can be very frustrating for a user who is trying to engage or interact with the page. Cumulative layout shift measures these unstable elements and how often they trigger unnecessary reflows. The lower the score, the better. So, there we go. Later in the course, as these metrics are mentioned with more frequency, you'll hopefully have at least some idea of just what they are referring to.